Well, regardless, you have school tomorrow. You don't have school tomorrow. You're gonna have to see me tomorrow. Um, I'm a I, I'm a anti-hurricane day. Imagine you date a guy named Milton.
That'd be kind of cool.
Okay, so we're gonna look at through those questions here.
Why did you send us the screenshot?
Huh? That's a different question. Shh. I want you to read through this question. If you can do part A, you can do part A. If you can do part B, you can do part B. The part C is something that I'm interested today is how fast the angle is changing. That's the harder part of the relay rate. First part, you already done it with the question. The answer was 16 over 15 on your homework on multiple choice. If you got 16 over 15, great. If you know how to do that question, you know how to do this question because it's exactly the same. Second question, you also done it because that was the one with the aerial triangle. And that one is also something that we did before. The only question that we need to work on is part C. But you can do part A and part B. So let's look at this question. Try it. Let me draw a picture, assign variables, and jump into the problem. I want to talk about your last test. So those of you guys failed last test, you have whole hurricane 4 days. Please don't spend time on TikTok, Instagram. Spend time on the test, going over it. You know, I might even have like a Zoom room open to help out with people with that. If people want to volunteer to help out with that, it would be awesome. I can do a small breakout room for them and to help out a student through there too. If you struggle, it's fine to struggle, but it's not okay if you're not trying to get better at it. You should know how to do part A. Laura.
Yes.
SAT's done. Moving on. I'm pretty sure you did better before though.
I didn't.
No, if you got to harder section, then you did.
I got to the harder section last time.
Yeah, but this time you probably can go further. You should have come to my class the other day.
After the second part was geometry.
Did they help you?
Yeah. Well, I did like. I did like questions that I wouldn't have.
Yeah, then that's good. I bet you increase at least 20 points.
You don't understand. Like I walked out of school so fast. I even forgot my water here. I swear.
The water bottle?
Yeah, like I forgot it in the testing room. I grabbed one. So fast.
You'd be surprised. You'll probably end up doing better. I would predict 30 points better than last test.
That's not bad. Still not
Hey,
bad.
you gotta take it little thing at a time. Small victory if you can get it.
Thanks for the teaching.
You increase 30 on math, 30 on reading, that's 60. And they soup the score too. So next time you just have to do one test better than the other test.
Yeah.
Yeah. You got this.
Thank you.
The conversation is so awkward.
I love making conversations awkward. Mr. Ye. See that you have rice today.
I always tell
I'm
people.
guessing my word of no subway came to.
Don't get me started with Subway.
It's so unhealthy for you, seriously. And my thing is like you go all the way there to get a veggie sandwich. You're munching on bell peppers and bread.
Yeah. No, the people work there, they will tell you that like a veggie patty is actually better than a meat patty. That's fine. You assign the bottoms B is fine.
Yeah. DV over DT.
Okay. So the first thing, draw pictures. It doesn't have to be pretty. It doesn't give you bonus credit. But I'm gonna try to draw it pretty. Even though I'm really bad at drawing.
That's not even fair, Mr. Yang.
What?
Because your iPad fixes it for you.
Oh, I'll get an iPad. 25 feet. Okay. They also say this foot of a ladder is moving this way, so it's 2 feet per second. Now this is a thing about a lot of you guys have problem with is when the bottom of the ladder is sliding 2 feet per second. Intuitively, like if I never met this problem before, intuitively I would think the top of the ladder is sliding down 2 feet per second as well, right? Like just without even like done this problem before, I would think that way. Does that make sense? However, it's not entirely true. It can possibly be true at one moment. It can be possibly true when they are 45 degrees. It's not always not true. Sometimes it can be true. Because imagine that if you have a ladder that is all the way down here. Oops, my bad. Imagine your ladder is all the way down here. How do I get rid of this? Yeah, how do I get rid of this ruler? Okay, so imagine you could be possibly two type of ladder, right? You could be like this ladder, like right here. Now imagine if you slide 1 inch here, it's probably only moved down ½ inch because not much movement. And if that doesn't make sense, well, think about it. If ladder is all the way here, if I move 1 inch, this is probably going to drop 6 inch because it's going to land on the ground. So it really depends. It's really relative. Is the base of ladder. What is the distance here? If you got a 45, 45, 90 triangle, then it can possibly be 2 feet per second. But the problem is not. The problem, they say base of ladder is 7 feet. So we say this is 7 feet from here to here. Now you can also using Pythagorean identity to find out what happened to the top of the ladder. So you know that this one's gonna be a little bit less than 2 because it's shorter on the bottom. Okay. So now we're gonna say, well, this relationship, I'm gonna assign variables. Now some people assign this as a B, like Laura. She assigned as a B, and that's nothing wrong with that. And the other one's gonna be height. That's okay. I assigned the X and Y just because I like to look at this X perspective and Y perspective. That's me, my preference. You don't have to do it my way. B and H, it just is okay here. So I could have said X squared plus plus Y squared is equal to 25 squared. Now, some people says I assign as A squared plus B squared equal to C squared. That's fine too. The only thing is you have to substitute the 25. Why is 25 valuable? Because 25 is something that never change. Because the ladder doesn't grow longer, the ladder is going to stay in the same spot, same length. It's not going to change. Now, why is that benefit for you? Huh? It's constant. What happens if you take a derivative of a constant? 0. So this is what you want to be able to see, that if you take a derivative of this, it's going to be 2x dx dt plus 2y dy dt is equal to 0. That becomes very valuable because anything that's constant, it becomes 0. Now, the problem that you did on homework with the 2 bike is writing one is writing toward the intersection and one's writing away from the intersection. That one, all 3 things are changing. The X is changing, the Y is changing, Z is changing. In this case, that you actually have your life a lot easier because 25 squared is a constant, take a derivative, it's gone. Not gone, it just becomes 0. So now I'm going to plug in everything else. So it'll be 2x, 2 times 7 times dx dt, which is also 2, plus 2y, then we had to figure out y. Well, what is y? What do you think y is? What is y here? Well, it's 7 squared plus y squared equal to 25 squared. And y squared equal to 25 squared minus 7 squared, which is 576 y squared. Y is equal to 24. So this is 24. At that instant, it's 24. So I'm going to say 24 here. dy dt, which is that's what we're trying to find, right? So that will be 28, I think, plus 48 dy dt. Now I'm going to purposely make mistake. Dy dt is equal to 28 over 48. What's my mistake?
You just subtract.
What? What is my mistake? I'm missing a negative. But also intuitively, physically, it makes sense because dy dt is supposed to be negative because the ladder is sliding down. It's very creepy to see ladder going up. Right? It should be sliding down. So this should be negative. How do we know it's negative? Because we subtract 28 on both sides. That's going to give you negative 28. So that's the problem, that where my answer is wrong. And you can simplify that as negative 7 over 12 feet per second.
How did you get the 2 times 7 times 2 again? No, it's
2 times 7. 7 is the base of ladder.
and then
2 is dx dt.
Oh, the 2 feet per second is that?
Yes. So if you look at the question, they say that it's sliding, pulling away from the at a rate of 2 feet per second. Is this okay? Everybody should get this. Now let's look at the part B. Part B says consider a triangle formed by the side of the house, the ladder and the ground. Find the rate of the area of triangle is changing at the base of the ladder is 7 feet from the wall. So same situation. There's a wall. There's a ladder. But this time I'm looking for what? This area, right? Area. So we're looking for dIdt. When the x is equal to 7, question mark, we still have dx dt is equal to 2. What are we looking for? What kind of relationship I have? Area of triangle? Okay, so 1/2 base times size, so area is 1/2 what? According to the variable I assign is x times y, right? Can I take a derivative with respect to time? Now what happened here? X times y. What can I do here? Product rule, good job. So it'll be dx dt times y plus x dy dt, right? And it turns out I know everything here. Dx dt is what? Y is 24, I think. Right? Plus x is what? 7. And dy dt is -7/12. And then that is the final answer. I mean, I can simplify that, but I'm too lazy. I'm not going to simplify that. But you can. You need to know how to add fraction, Mariana. The mistake she makes is like really bad. If you have a problem, I'll teach you. I have no problem teaching people how to add fraction.
Because I didn't know that.
Okay. Last year I have a student doesn't know how to multiply 25 times 25. He thinks it's 7,025.
How?
Ask Aiden. Aiden Ruder. That's so this is the question that is very important for today. They say, hey, C, can you find the rate of change of angle between the ladder and the wall? The house changing when the base of ladder is 7 feet from the wall. So it's still 7 feet from the wall, but they say find the rate at which the angle is changing. Well, what is that? Is that dAdt or dVdt or dxdt? What is it? D theta what? Good job. How do you know? That was a very good guess. It's actually very nice. That was kind of cricket. So they also told you that there was a ladder, right? And this ladder is sliding this way, 2 feet per second. Now let's go back and look at the question. They says, find the rate of change of angle between the ladder and the wall. So which angle are they talking about? Huh? The what? The top one. Good. So is this one, right? Now here's the thing. When you go back to all the relationship I give you from the first day, which relationship I'll be using in this case? How fast D data dt. SOHCAHTOA, good job. And I also told you something else in that section. You want to find out how fast the angle is changing. What else you have to pay attention to? Constant as on where? On the bottom. Good. So I have option of 6 different trig function. Sine theta, cosine theta, tangent theta. I could have cosecant theta, secant theta, and cotangent theta. Now, which one is constant on the bottom? SOHCAHTOA. Which one? Yep. So this is 25. This is 25. There's only one that was hypotenuse on the bottom, right? And imagine the other one. This one's y over, or actually x over y in this case, because the problem's on the top, and this is y over x. This one you have to do product rule, so this is not a good option. Boom. But sometimes those are the options. And secant is going to be 25 over something and 25 over something. Those are not good option because you got constant on the top. Why constant on the top is bad? Because if you take a derivative, it's going to be x to the negative 1 power. So you prefer to be this too. Now, which one you prefer? Sine theta equal to, in this case, is x over 25 because we assigned this is x, this is y, or y over 25. Which one's better? Y sine's better. We have the x. We also have a dx dt, which is that's the things that you want to do. So sine of theta is equal to x over 25. That will be a relationship. Do I need to take a derivative of this? Yes, I can. What's derivative of sine theta? Cosine theta, what else? Cosine theta, what? Chain rule. No. What's derivative of sine theta? Yes, look. Yeah, d theta dt. This is a chain rule. There's a 2 layer. First layer is this. Second layer is this. Is equal to 1 over 25 dx dt. Which is we only need find out what d theta dt, right? So d theta dt is equal to 1 over 25. dx dt is 2. And this one's going to be 1 over cosine theta.
Shoot the cosine theta times d theta over d theta.
What?
Like the cosine theta times theta. D theta.
Because of the chain rule. If you take a derivative outer layer, it's cosine theta. And then you take a derivative of inner layer, it's d theta dt. So this one's going to be 2 over 25. Now cosine theta is, we can go find out what happened to cosine theta. Well, cosine theta is equal to adjacent over hypotenuse. So we know it's something over 25. Adjacent in this case is y, but y is also known as 24. So it'll be 24 over 25. Well, it's 25 over 24, sorry. 25 over 24. Why? Because it's keep change foot.
Oh.
So the 25 cancel out. Wait, hold on a second.
Did you multiply 12 with
Where the 2 is, hold on a second. The 2 is on the numerator. I make a mistake somewhere. I don't know. Oh, this should be 1. Sorry, this should be 1. Thank you. I think Mariana's right. So this should be 1. So this will end up to be 1 over 12 radian per second. Now you probably have no idea what's 1 over 12 radian per second mean. Well, 1 radian is roughly 57.3 degrees. So 1/12 of that, which is roughly about 5 degrees, somewhere around 4 degrees change, because the 57 divided by 4 point something degree per second, which is kind of makes sense because the data dt should be getting bigger. If I slide it down, the angle should be bigger. So that's gonna be 1 over 12 radian per second.
That's weird. Why can't you just multiply the 2 to 1 over 25?
I did. So it'll be 2 over 12, 24.
Oh,
Wait, wasn't our base 7?
What?
Isn't our base 7?
The base is 7. Hold on, let me see. Oh, it's 7. You're right. Wait, hold on. Wait a second. Wait a second. It's adjacent, right? Adjacent is 24.
I know, but
It's opposite over hypotenuse. X over 25, yeah.
yeah.
it's the derivatives. Change. Because you picked sine because we knew the value, but then when you took the derivative,
And now if I move to the other side, it's gonna be 1 over cosine is secant. Secant is gonna be hypotenuse over adjacent. Adjacent is right here. This is 24. So this is adjacent to the angle. Laura,
Yeah.
comprende?
Sine theta is b over 25, right?
Sine theta is b over 25. Yes,
So why can't we put 7 over 25?
because we have to take a derivative with respect to time. We have to find the rate of change. Because if you just plug in, then you don't find the rate of change, how fast the angle is changing. You might be able to find out what is the angle, but you won't be able to find out how fast the angle is changing. Does that make sense?
Mhm.
Yes?
so if we only know like x and not like y, should you pick
I pick x because dx dt. Because what if you find dy dt wrong? Then I won't use y. I could have used y as well, but the problem is your dy dt has to be correct on the previous evaluations.
so if you only have 1, should you pick what's never mind.
I'll pick the one that is known, that's given, rather than I'll pick a dy dt, which is the one I evaluate. You're gonna get same exact thing if you got a correct dy dt and use cosine. You're gonna get same exact thing, but you take a chance if you get that first question correctly. Got it? Okay. Any homework question you want me to go over? Maybe the intersection one or things? Yes, Leah.
Number 6.
What's number 6 says?
You wrote it.
Is that the one you're gonna ask, Amber?
No, I was gonna ask number 4.
The cube one?
Yes.
Okay, I'll start with the cube one. No, I'll start with the intersection one. So it's okay if I go over the intersection one first? Okay. So if something due north, what does that mean? They are north of the intersection, right? And I forgot how far they do north. So this is 8. Is that okay? And it's going toward the intersection. And how fast? So what is it?
16
So we're gonna say dy dt equal to 16. But what's wrong with 16? I think there's something wrong with 16. It's decreasing, right? So it should be negative 16 mph. Is that okay? And there is some things due west. Never eat soggy waffle. So waffle is right here. Are they going away or going toward the intersection? Towards? Away.
Yeah, it says 10 miles due west intersection away.
10 away. So what is dx dt here? It's a negative 12, positive 12. It's increasing. So it's positive 12. So it'd be x squared plus y squared is equal to z squared y. Why is z? Because this one has no constant. So it'd be 2x dx dt plus 2y dy dt equal to 2z dz dt. Is that okay? So 2 times x, we're going to assign this to x, this is y. So this is 10, dx dt is 12, plus 2, y, what is y? 8, dy dt is negative 16, right? Equal to 2z, and we don't know what z is. What z is basically a triangle where you have 8 and 10. This one's going to be square root of 164. Why do I know square root of 164? Because 10 squared plus 8 squared is equal to 164. So this one's going to be 240 minus 256 is equal to 2 times z is square root of 164 dz dt. So therefore it's going to be negative 16 over 2 square root 164 equal to dz dt. And you can take out 2, so it'll be negative 16 over 4 square root 41 dz dt. And you cancel out, that's going to be 4, so it'll be negative 4 over square root 41. Yes?
dx over dt, when will it be negative? Like, what type of problem?
Is because they walking toward dx dt if the somebody's due west but it's going toward the intersections.
So,
If because you're going toward, the distance is getting shorter, right? So that becomes negative. But you're going away, then it's positive. dy dt? Dy dt is because it's going towards the intersection. If he goes away, then it'll be positive. It's not, it's relative. So that's why they say it's related rate, is everything's relative to each other. Okay, so yes. Amber, which question is that?
Number 4.
Is the volume of a cube of ice is decreasing at a constant rate of 10 cubic centimeters per minute?
By the way, this is the answer.
It's been like 1 day since I so fucking already broke. How did it like break out the seas? I'm so confused.
Now let's talk about the Amber's problem is the cube. So question 4 is a cube. And last time Leah already teach you how to draw a cube. I don't know how to draw a cube, but I know how to do math. Okay, so they say a volume of cube. They say volume of cube. So that's equal to s cubed. And they also ask you surface area. So surface area is equal to 6s squared. Now, why is that important? Because they give you 2 things. They give you the volume of ice is decreasing. So what it means, dv dt is what? Negative what? 10. And feet cubed per minute. What is the rate of change of the, they looking for dsa dt? Question mark. Is that okay? So I'm going to take a dv dt equal to 3s squared ds dt. Hopefully you got that. And you should get -10. And this is what happened with psi. Psi is 5. So it'll be 3 times 5 squared, which ds dt. Now, why do I need to find ds dt? Because dsa dt, if you take a derivative of dsa dt, so sa equal to 6s squared, then you need a ds dt there to evaluate for dsa dt. So I hear it's going to be -10 over, I think 75, I'm not sure. And that's equal to -2 over, what is it? 15. So then -2 over 15, so it'll be dsa dt is equal to 12s ds dt. So it'll be 12 times s, which is 5, times ds dt is -2 over 15. This is going to be 3. This is going to be 4. That's going to be -8. It's -8, right?
Did that, but I did not. I thought the answer would not do that.
How did we get dsa over dt?
dsa dt be 6s squared. Sa is equal to 6s squared. And if you take a derivative of that, it's 12s ds dt. Now you should do that. If you didn't do that, it's probably on the test I cannot give you credit, or somewhere along the line with that.
What if I got that, but I didn't do the DSA thing? Like, I got -8, but I didn't do it. Like, I didn't use the same variables and things that you did.
You don't have to use same variable, but you can say dA dt if you want.
Okay, I put like DV.
You have to get dV dt to get ds dt first. You should get ds dt is -2 over 15. Did you get -2 over 15?
Or ds
Oh, yeah, right here.
Okay, and then you plug in, like, say, area equal to 6s squared. I just call it SA. I don't have to call it SA, but I can call it A if I wanted to.
I first found DV over TS, and then I did TS over DT, and then I found, like, I just simplified.
Yeah, you gotta find out what's dA dt first, though.
Yeah.
Okay, yes, Lalia?
Could you explain why for number 6 it's decreasing again?
Because it's negative. I think.
It's because you said it's going towards the intersection.
It doesn't matter. It's if this value is negative, then it's decreasing. It's -4 over root 41. Questions? Questions? Yes?
Why do we need to be taking a derivative for these problems?
Because you're looking for rate of change. You're looking at how fast things changing. Like, see, if I want to see how fast the hurricane is moving, right? Or how much the radius is increasing, right? The hurricane is actually increasing radius as it gets starts small and gets bigger and bigger. It's actually, the hurricane actually have a lot of, if you pay attention to hurricane calculations, actually fairly easy. You just need to, it's pretty complex, but but the basic thing is you looking for the pressure. They always give you a pressure. They will say it's 1,000 millibars. When you get to 948, you're in trouble. 948 bars. That means the pressure is gonna be very low, and that's gonna increase the speed very fast, and also the water temperature. So all the calculation there is all involved is related to everything. So how fast the speed, they call it rapid intensification, which is how fast the now because the water is so warm, so it can increase. But when it increase, also make the pressure goes lower too. So very very cool math problem actually. But yes, you have to think about, you have to take a relative respect to time because you know the rate of change. So if I know the rate of change of the pressure, I know the rate of change of the water. The water gets warmer, then also knows how fast the water is gonna, how fast the hurricane is going to be, or how big the hurricane is going to be. A lot of time people think about like nothing to do with math. Everything's to do with math to predict the speed. Except I thought their prediction 2 days ago was awful, because a prediction was predict to be here of category 2. And I look at it, how far is it and how warm the water is, it just doesn't make sense. Because at the time it's 40 miles per hour. Huh? I think right now it's already category 4. And that's the temperature in the Gulf Coast. What?
It's gotta be.
Wait, it's 4?
It's about to be 5. And I predicted like 2 days ago. I told my wife, there's no way this is a 40 mile per hour. Because you have so far distance to go through the warm water, it just doesn't make sense.
Oh, yeah. Oh, no, thank you.
So the problem is that like if you look at 2 days image, I don't know if you saw 2 days ago when somebody posted. I think it was you, right? Somebody posted. They say it's predict to be here at category 2. And I was like, there's no way.
It's gonna be 5. My friend was telling me.
And that's the water is a lot colder. Huh?
It's gonna be like a 5.
It's gonna cover whole Florida, but the main part, the eye, is gonna go to Central Florida.
The eye is like the
The eye is the fastest part. Actually, if you ever been through a lot of hurricane before, if you go through the eye is completely peaceful.
Yeah, I said it. The band are like.
The eye is gonna be peaceful for like 30 minutes though, and then it's gonna be really bad. We just hope like water is getting colder from the last hurricane. The water is colder from the last one.
Without Wi-Fi, we don't have.
Huh?
So we need Wi-Fi. To see you, Mr. Yang.
So yeah, it's okay.
Wait, what?
Pretty sure you guys have Wi-Fi by Wednesday, but it's just like nighttime on Wednesdays. Probably.
Wait,
Huh?
are we not gonna?
For sure, no. Yeah. It's almost guaranteed, and that's that the hurricane decided to go north, like alternately. Which is that's gonna be worse because it's gonna hit the oil rig, and all the gas price is gonna go up.
Literally, I got Subway over the weekend and I thought I was like, this is a non-stick veggie sandwich, but it was so bad. I didn't even like good Subway.
Wait, you got veggie sandwich?
Yeah.
Veggie patty? Or
No.
veggie? You should get veggie patty. You should get no veggie sandwich is not. Veggie patty.
I'll try.
You just show up today.
I did show up here.
He knows the next 2 days not gonna be here.
I got a 7-day weekend coming up. Listen. Here's the method. Wednesday we get off. Thursday we get off. Friday, hopefully we get off. I'm pretty sure get the same. Saturday, Sunday, Monday there's no school. Tuesday.
Wait, Monday's no school?
Teacher work day. Yeah. Tuesday's the SAT. I opted out. 7-day weekend. 7-day weekend.
You already planned out everything?
I have this ready. I need Friday off. I have to get Friday off. I'm so excited. I tried to best to get off.
They're just gonna fly to like different states.
I'm gonna be in Mars.
This hurricane's gonna be bad.
Yeah. And there's another hurricane coming right after this. What? Oh my god. It's like full on. It's supposed to be destroyed. He wasn't here for a month. You okay, bro? Fantastic. Thanks, God. That's all I've ever wanted in life.
Should I do this? I don't know why everybody already. I think this should be on the radio.
What?
Hi. I don't know. I don't have Yeah, that's the one. My wife did it. That's the first time. You're like, you work on this. They're like, not stuff.
Give it off.
Not too hot.
They get it with a book at 34.
No,
Now we're bro. This is you, bro.
My wife is different. It's like boring. Yeah, I don't.
I said you just say.
Yeah, that's it. Next me, did you watch the video?
What? I was so sick yesterday.
November 7th.
I'm fine now. I'm fine now. I went to the doctor and everything. It was just like,
Hey,
I don't even know.
it's gonna go right.
Yeah,
And
They got a texture. I think put any texture on. Bro, I'm telling you, get like these on pretty fun. I got you. I'll be fine. No, I got you. I'll bring it tomorrow. Like I'm so dead on. I got you.
I know, but I'm like, it's not his life yet.
What?
I
It's
mean,
not even bad, bro. It's
when y'all are excited.
Just text me and I'm about to put you on. Watch. I thought you saw the door turn around. Don't worry. Don't worry. You gotta sign
What
happened?
Yeah, I told him
I'm not.
a little bit. Oh, it's not okay.
I promise you.
Come on, bro.
I got you.
Come on, bro.
I got you. Tomorrow, in this period, I'll get
NCF too. Oh?
Because more likely,
No picture. You're supposed to.
Alright.
We're doing notes, right?
No, we did notes last time. Now we're gonna give you actual practice problem.
Okay.
The practice problem is. Oh, actually, I'm gonna show you the last part of the things. If I use right ribbon sum. Oh, left. Yeah, right ribbon sum.
Left. We did right.
We did right. Alright, shh. This video last week I did finish it, but if you're still confusing, you can go watch a video. But this is a this is left Riemann sum. Left Riemann sum I used left. Hold on, I'm gonna show you the thing.